Colin at the Rotary about a month and a half ago, or steered somebody toward booking him. And he was so good that I thought we should repeat it and invite the general public. So here you are tonight. Colin is studying atmospheric study at atmospheric science at Cornell, and I'll let him carry on and tell the rest.
Thank you.
Thanks for coming.
Can everybody hear me if I don't use the mic, or would you rather me use it?
Use it.
Use it? Okay. Okay, is that better?
Yeah.
Okay, awesome. So yeah, thank you so much everybody for coming out tonight. Really appreciate it. As Kevin said, my name is Colin Evans. I'm going into my third year at Cornell, studying atmospheric science, focused really on the dynamics of how drought happens here in the Northeast. And that might be not something you all hear about a lot, especially in the Northeast. We get a lot of rain, as you all know, especially the last couple months. But as we go through my slides, you'll see that we do get drought here, and it is costly. I'll definitely take questions at the end. During my talk, if I throw out an acronym that I haven't explained yet, we have way too many of them in sciences, and especially climate science. So just yell at me and I'll explain it, but hopefully going through I won't use too many. So when I give public talks, I like to get started going over the perception of climate science and climate change that the general public has. Now, Yale University has an entire department on climate change communication, and they send out these really in-depth surveys on all sorts of information, how people feel about climate science, what we think they should do about it. So we have county information here in New York, and so this is the percent of Tioga County that thinks global warming is happening, and 65%, so the majority. It is down from 70%, which is the national average, but 65%, so that's not too bad. Then when we look at, okay, what percentage of the adult population is worried about global warming, it drops a little bit, down to 56%, also down 5 from the national average. Interestingly, when you look at the percent of adults who think global warming will harm future generations, that actually goes back up to 68%. So 56% are worried about it, but 68% are worried about future generations. So that's kind of an interesting statistic. As you can imagine, percent that think global warming is caused by humans, down to 53%, which is 4 below the national average. And then the one that really hurts me as a climate scientist, which tells me that we have a lot of work to do, is that only 44% of adults know that there's a scientific consensus that humans are causing global warming. Because in reality, it's 97% of climate scientists are in agreement that human activity is causing global warming. So how do we know that? We need to look at carbon dioxide. The Mauna Loa Observatory in Hawaii at the Scripps Institute of Oceanography have been taking carbon dioxide measurements in the air for the last 60 years. And they publish daily reports on what the parts per million of carbon dioxide in the atmosphere is. So this is from just like a week ago, and this is a 2-year graph. So this is right here, June of 2017. You can see there's kind of an annual cycle where the high is in May and the low is in September. I'll show you why in a second. When I gave this talk for the Rotary about a month ago, I had a more updated slide for the beginning of May. And for the first time in human history, we went over 415 parts per million. So we reached a new milestone this year. So this is the entire time series that the observatory has been taking those observations. They started in the late 50s, and you can see we were about 315 or so parts per million, up to today, about 414, 415 parts per million. So in just the last 60 years, we've added 100 parts per million of carbon dioxide. But we need to put that in a larger context too, and look at a much longer range of time. So we can get direct measurements of carbon dioxide from ice cores. We go to Greenland, we go to the Antarctic, we drill down. They can precisely date when that ice formed, and so they know exactly what the carbon dioxide concentration was in little trapped air bubbles in the ice. And You know, a lot of people will say to me, well, Colin, you know, the climate has changed before. Yeah, that's, you know, like telling a doctor that people get sick. We know. But the issue is the rate of change. So these highs, these are called interglacial periods, where they were pretty much relative to pre-industrial times. But where these dips are down, these are all glaciers, right? It'd be an ice age. And the difference between an ice age and not an ice age is not a lot. It's only about 100 parts per million. Now for context, as I mentioned, 415 parts per million, first time ever in human history. About 300,000 years ago, that's when modern humans showed up. And then today. So when I've shown this graph in the past, people don't see it right away. Because you're focused on all this stuff, all this activity over the last 800,000 years, and you're not paying attention to this line. That's not the end of the graph. That's what we've done since the Industrial Revolution. So, yes, the climate has changed in the past, but we're adding so much carbon dioxide at such a ridiculously quick rate that the climate system is coping with that in very dangerous ways. So I mentioned that there's that annual cycle of carbon dioxide. That's a result really of geology. Most of our landmass is in the northern hemisphere. So when the northern hemisphere goes into spring and summer, all the vegetation of trees, plants, everything, they suck up a bunch of carbon dioxide out of the atmosphere. And so that's why you get a low at the tail end of northern hemisphere summer, so like September-ish. And then it begins to increase as vegetation dies off, and it peaks in early May. And so this is just showing through time, and the yellow is the carbon dioxide in the atmosphere. Okay, so why is carbon dioxide a problem? I'm sure you've all heard of the greenhouse effect. If we didn't have an atmosphere, our planet would be pretty much entirely inhabitable. Without it, it would be 0 degrees Fahrenheit, pretty much everywhere. Much colder, of course, at the poles. But the average temperature of Earth is actually 60 degrees, and that's because of our atmosphere. So the atmosphere traps heat coming in from the sun. Everything that we power comes from the sun. Now, this little guy doesn't really look that scary, right? It's just carbon dioxide. It's one carbon atom connected to 2 oxygen atoms. It's called a linear molecule. The problem, though, is that this molecule can kind of dance, can stretch, can bend a little bit, and that's called a vibrational mode. So I'm going to get a little bit into the weeds here with the physics, and I'm doing this because every anti-climate science paper I've read never addresses this. And they don't because it's irrefutable. And if they did talk about it, it would just be garbage. So I'm going to walk you through all this. These are called absorption spectra of different molecules. So there's carbon dioxide there. These are a little bit hard to read. They go backwards for some reason. So the top is 0% absorption of radiation. The bottom is 100%. So this is the spectra for carbon dioxide. And you can see that there are 3 specific areas where carbon dioxide, at a specific wavelength of radiation, it absorbs almost all of it. So then we need to look at what kind of radiation would that possibly be. So these top curves are called black body curves. Every object emits radiation, and it will emit radiation at different wavelengths based on its temperature. So this one here, at 6,000 Kelvin, which is like 6,200 degrees Celsius, very warm, is the sun. And most of the wavelengths of the sun radiation is in the visible spectrum. That's what we can see. And the y-axis is intensity of that radiation. So those first 2 ones of carbon dioxide are about 1.5 to 2 and 3-ish. And they're really just at the tail end of the solar spectrum. So not a lot of the solar radiation that's coming in can be absorbed at those wavelengths by carbon dioxide. But then when you look at 15 micrometers of radiation, it's a totally different story. Because that's the peak of terrestrial radiation. So most of the radiation, long-wave infrared radiation, that the Earth itself is emitting can be absorbed 100% by carbon dioxide. And that is really what the problem is. So the more carbon dioxide we put into the atmosphere, the more radiation it can absorb from the Earth itself. So the more it absorbs in the atmosphere, it re-radiates all over the place. Some of that's going to come back to the Earth and re-warm it. That's the greenhouse effect. And we can see what those results are. So this is an animation just showing circles of temperature change since 1850. And you can just see as time goes on from the baseline. So this is compared to the, did that shut off? Low battery. So compared to the 1850 to 1900 average, it's getting warmer. Now we can look at that in terms of a map as well. These are temperature anomalies. Blue is colder, red is warmer, and it's based on the 1950 to 1980 average. And you can see really now after the 80s, 90s, 2000s, and it's getting warmer. We have the observations for that.
Are you going to go back and show us methane, the curve for that too? I didn't really look at it.
I'm not going to focus on methane in this.
Okay.
It's a different problem, and we can talk about that afterwards.
Okay,
Absolutely.
all right, thanks.
But it's not just temperature. So there are other vital signs showing us that it's warming up and things are changing. So despite some attention-grabbing headlines, over the last decade or so, Antarctic ice mass is decreasing. And it's decreasing at a rate of 127 gigatons per year. The Greenland ice mass, almost more than twice that, 286 gigatons per year is decreasing. Arctic sea ice is decreasing. And sea levels are rising. These are all direct observations and measurements that we've been taking that show that these things are changing. But importantly, it's not just us that's seeing this stuff. There's a world of agreement across the globe that temperatures are rising. So that first blue line that went, that's from the Met Office in the United Kingdom. Then NOAA, the National Oceanic and Atmospheric Administration, was agreeing on. That purple line was the Japanese Meteorological Agency, the Berkeley Earth Observatory, and the NASA Goddard Institute for Space Studies. All of their observations agree with each other. Across the globe, annual temperatures are increasing. Now, a lot of people like to argue with me about this stuff. And two of the most common ones they bring up are, well, it's actually volcanoes, or no, it's actually the sun. So I'd like to address those. So the first, we'll look at volcanoes. So what this graph is showing us is the comparison of emissions from fossil fuel burning versus emissions of carbon dioxide from volcanoes. And this purple line, it's a little hard to see, almost looks like the x-axis, is the emissions from volcanoes, compared to this green line, which is the emissions from fossil fuels. So very clearly, it's not carbon dioxide from volcanoes. Additionally, if it was, if there were enough volcanic eruptions to emit that much carbon dioxide, we'd be in a nuclear winter. The volcanoes also emit aerosols. They get trapped in the stratosphere and reflect solar energy. In 1992, there was a huge eruption at Mount Pinatubo in Indonesia. And we actually did see like a 2-year drop in temperatures because there was so much aerosols in the atmosphere reflecting sunlight. So it's not volcanoes. Okay, well, what about the sun? So, since 1960, you can see temperatures in this red line are increasing. Solar activity is decreasing. Also, the difference between, these are units of watts per meter squared. The difference between 1361 and like 1360 in terms of global temperature capacity is 0.08 degrees Celsius. We're seeing a lot more warming than that, and it's decreasing. Also, if it was the sun, the top of the atmosphere would be warming up, because that's where ozone is, and ozone can directly absorb solar radiation, but that's not what the observations are showing. Most of the warming is occurring down here at the surface. So it's not the sun. Okay, so who's emitting all this carbon dioxide? That's a couple years old, but it's from 2016, and should be no surprise, most of it is coming from China. You see, they are emitting a ton of carbon dioxide. But I don't think this is a fair statistic. I think we also need to look at per capita emissions, because that tells us a really different story. You can see China then drops down a ton, and then we really show up. So does Australia, a couple of the countries, the oil-producing countries in the Middle East, Canada too. So when you look at per capita emissions, we're individual Americans emitting way more than pretty much any other country on the planet. And this hasn't been changing. So 2018, we emitted more carbon dioxide than any other year previously. So this graph is interesting. So this red is China. See, obviously they've emitted the most. This gold is yellow. This light blue is the United States. This dark blue is the European Union. So those four entities combined emitted more than the entire rest of the world. Also, let's look at the US versus the EU. That's about 1.5 times more emissions from the US. EU is what, 28 countries or so? 520 million people, where one country, 330 million. It's a lot. If every person on the planet lived like we do, consumed resources like we do, we'd be in a much worse position than we are now. Another really important thing I want to talk about is that weather and climate are different things. And an analogy that I like to use is that imagine you're walking through a park. You're starting at point A, and you need to get to point B. So you're going to take this path up. But you're also walking your dog, and say they're on a 10-foot leash. They can go ahead of you, they can go behind you, they can circle around you, they can stop and sniff the grass for a little bit, but you're the one holding the leash and dragging them along. So they need to follow you. So it might seem like they're not following your path and might be completely going backwards from what you're doing, but ultimately they're going to follow along because you're the one with the leash. And that's pretty much weather and climate. Weather can do all sorts of crazy stuff in short amounts of time, but it's going to follow the trajectory of the climate. So we can look at a real world example of this. Everybody remember January, that polar vortex when we got a blast of really, really cold air from the Arctic? I do, it was awful. And I remember seeing lots of tweets, especially from prominent politicians, saying, what's going on? I thought global warming was happening. Well, we need to take not such a myopic view of the world and really see what else is going on out there. So, this is from NOAA, the National Oceanic and Atmospheric Administration. When you averaged out January, it only brought the eastern United States to near average. Even though we had those record-breaking cold temperatures, because the rest of the month was warmer than normal, those cold temps only brought us to near normal. But that's just the eastern United States. Look at the rest of the country, rest of the globe. That's mostly red. Australia in particular had a ridiculously warm January. So these are temperature percentiles. We can also look at the temperature anomalies too, and we see the same thing. Pretty much just normal for us in the eastern United States, but around the world, it was warmer than normal. Okay, so what does this all mean then for the Northeast? The Intergovernmental Panel on Climate Change, they release a report every 7 years or so, even though they call it the annual report. The most recent one was AR5 in 2014. But they set these emission pathways, and they're all just based on different emission scenarios, how much carbon dioxide we continue to emit. So the one I'm going to focus on really for the rest of the talk is this one's called RCP, Representative Concentration Pathway. I don't know why they call it that. 8.5. And really what we call that is the business as usual scenario. This is the scenario where nothing is really being done to limit our carbon dioxide production. And I'm focusing on that because that's what's happening. We're not doing enough, or really much of anything. Like I said, 2018 being the year we emitted the most carbon dioxide. So we can look at climate models and how they project temperatures into the future. So this is projections of higher emission scenarios and lower emission scenarios for average daily maximum temperature in Owego. So we're just about here now. Average yearly max about 58. By 2080, we're getting to about 65. So it's warming up. And we see this in observations as well. Interestingly, when I made this presentation for the Rotary like a month ago, where I found that we're warming up more quickly in Tyler County than any of the other counties around us. So we have a warming rate of 0.7 degrees Fahrenheit per decade, which is warmer than any of the other counties, like I said, around us. I have no idea why. When I found this out, I was super surprised, and I was like, cool, there's going to be my third dissertation chapter. figure this out. No, I really don't know, but found it very interesting. And what's happening with all this? Billion-dollar disasters. So NOAA, they track billion-dollar disasters throughout the year. 2017 was very expensive, particularly with Hurricane Maria, Irma, and Harvey. 2018, similarly, very expensive, especially with Hurricane Michael, which was the strongest hurricane to make U.S. landfall, Hurricane Florence in the Carolinas. But these are increasing. These events are increasing. So this graph is a little bit hard to read because it's month throughout the year here, and then this is number of events. So you have to kind of read it like this. So you can see like the amount of billion-dollar disasters in December are increasing. Here's the average, and then here are years in the last 10 years. And they're 2011 being the most, but 2017 is up here, 2018, 2016, and these are all the years before that. So they are increasing. Each month is seeing more and more billion-dollar disasters. What I'm focused on with my research at Cornell is drought. Funny time to be talking about drought in the Northeast, especially the last couple months with just how much rain we've been getting. But we do get droughts here. So this is an image that's showing what we call the Palmer Drought Severity Index, which is just a metric for us to measure drought severity. This is from July 2016. And you can see Tyler County here, and a large portion of the county in this -3 to -4 range, which is incredibly dry. Those are the kind of numbers you see with really severe southwest droughts. So very, very, very dry. But you also got to compare that to, okay, well, what's normal? So should be no surprise. Normally, our soil is pretty wet. The U.S. Department of Agriculture categorizes the state into different agricultural regions, and so we're within region 3 here. 2016 alone, it was just a seasonal drought. We saw $1 billion lost in agricultural products that year. In New York, it's a $5 billion business, so 20% just from this one seasonal drought was lost. For region 3 specifically, about 75% of fruit crops, vegetables 58%, other ones were 55% that were pastured in fields that were unusable. And some farmers, especially in western New York, you can see how this extreme drought, there are a lot of berry farms out there, and some reported 90% loss in their yields in 2016. So here's a time series of drought. One I'm focused on in my research recreating is this 1960s multi-year drought. That's probably the worst one we've seen on record over the last 60 or so years. In comparison, there's the 2016 one. So you can see how bad that 1960s drought was. Now we talk about drought, the main drivers being temperature and precipitation. So if we look at the max temp projections that are days above 100 degrees Fahrenheit, sorry, in these high emission scenarios, this red here, you can see we barely get those days now. We really don't get days above 100 degrees Fahrenheit. But by 2080, the average showing about 10, whereas some of the higher ones are over 40. Over 40 days where the max temp could be above 100 degrees Fahrenheit. And this is troubling for not just drought, but we also have to consider how this might impact these batteries really don't last. How they might impact our vulnerable populations, so the elderly, children that are left outside, and agriculture too. Not all livestock does great in really warm temperatures.
Or people.
People too. Yeah. Okay. So, temperature being main driver of drought, also need to look at precipitation projections. Interestingly, both the lower emission scenarios and higher emission scenarios look about to be in agreement with each other. That over the next 70 years or so, maybe a slight increase in projections for precipitation. I put the observations on here for reference, these gray bars. Anybody tell what that year is? 2011, yeah, we all know what happened that year. So, okay, it'll be warmer, but maybe more rain. So this is a map showing the percentage change in precipitation. So by 2084, you can see maybe 5 to 10, maybe 10 to 15% more rain on the annual average. But you can't just look at the annual average. You also have to look at the seasonal. Remember, 2016 drought was seasonal. 20% of agriculture products lost. When you look at summer precipitation, it's a totally different story. So we're losing a lot of rain in the summer in these projections. Combine that with those increased temperatures, and this is a recipe for bad seasonal drought. So what I'm doing at Cornell is looking at these projections in the future, under those different emission scenarios, finding out what are those main drivers and how can we mitigate for the future. When you combine all these projections and look at just soil moisture, this is the result of that. So these colors are soil moisture, where the bluer is wetter, the brown is drier. So this is showing literally the entirety of the contiguous United States drying as a result of this combination. What would this do for the weather in Owego? By 2070, if we continue emitting carbon like we are, it would move our climate basically to what is currently experienced by a town called Mount Vernon, Georgia. So I thought I would compare what those are like currently. So this turquoise color is us, and this orange is Mount Vernon. So this is average max temperature throughout the year. You can see for a good 3 months of the year, average max above 90 degrees. And importantly, average max is never below 60. This would be really important for us in the winter. Winter snowmelt contributes a lot to our soil moisture for early spring growth for crops. So that could be a potential issue, not to mention the decline in snow season tourism that the state has going for it. All things to consider. I also thought humidity would be a good one to look at. Again, the same colors, orange is Georgia, turquoise is us. So imagine, 90 degrees, 90 year. Again, this is harmful to us, to our vulnerable populations, agriculture. This is a real potential problem. So the biggest climate change threats to the Northeast, as I see them, are drought, especially seasonal drought. My advisor, his name is Dr. Toby Alt, he studies the risk for mega droughts in the Southwest. Those are like 30-year-long droughts. Now I'm going to be adapting some of his techniques to look at our drought risk in the future. Heat waves, especially, as I mentioned, in terms of affecting our vulnerable populations, and extreme weather. I showed you that the rise in extreme weather is happening, and it might seem contradictory to talk about drought and flooding, but that's what we're seeing. California just got out of a really bad drought. And in the Midwest, though, all that rain's been carried over, and they're experiencing devastating flooding. So we're seeing this stuff happening. Despite all that, I do have reasons for hope for climate science and for us. There were only 66 years that separated the Wright brothers at Kitty Hawk and us landing on the moon, which to me is just an incredible feat of human achievement. And I've read some papers that kind of say the same kind of investment to get men on the moon would be needed to really redo our infrastructure for renewable energy. So we've done it before, and we could do it again. But there's lots of stuff going on too across the country. So this might be a little hard to see in the back, but there's a bunch of orange dots on here. These are all cities that support reducing their emissions. And then the colors of the states are how many state-related mitigation activities are going on. So for example, Miami is spending $500 million to build really strong pumps and raise their streets and sidewalks because they're already dealing with issues of sea level rise. This is a little outdated from 2015, but we are adding a bunch of wind and solar energy to our infrastructure. And then for me personally, solar energy is what gives me the most hope. And this is why. In the US, in 2017, we consumed 3.82 trillion kilowatt hours of electricity. The amount of solar energy that hits the Earth in an hour is over 4 times that much. In 1 hour, more energy than what we used in all of 2017. The sun has everything we need. We just need to figure out how to harness it. Kids also really give me hope. There were the Kids Climate March that happened this past March all over the world. This is from Australia, but it was everywhere, New York and Boston and Paris and London, everywhere. And this is really important to kids, and they're really making that known. And of course, there are ways that we can help. So, 83% of adults in Hubbard County think we should be funding more into renewable energy. That's a huge majority of people. Like, no politician can fight that number, right? That is almost everybody. Similarly, 78% think we should be regulating carbon dioxide as a pollutant. Again, that's a huge number. So when you're voting, look at who's in support of these things. If they're not, talk to them. So this is Tom Reed, who was our congressman for New York 23. The League of Conservation Voters give an environmental scorecard to every politician. Tom is not doing so well at 17%. If he's around this Saturday for a strawberry festival, talk to him about this. See what he thinks. See if we can convince him to get some money into renewables. Another good resource, who I'm sure will be around on Saturday, is our state senator Fred Akshar for New York 52. He's a little bit better at 38%. I have personally corresponded with him, and he hasn't seemed too receptive, but like I said, 83%, 78%. if that many people were making their voice heard, he changed his mind.
Strawberry Festival, did you say?
I hope so. He's been there before. There's also something called the New York Climate Smart Communities, and they work, there's state grants and federal grants to help us on cost savings, become energy independent, improve our air quality. They work to conserve green spaces. For us, they would help reduce our flood risk and invest in the economy. Back in December, I wrote an op-ed to the Penny Saver about us becoming a climate smart community. And I was really excited this past March when the trustees voted for the solar energy for the village, which I think is really great. And that's a great first step. But becoming a climate smart community, there's a lot more we can do. On a personal impact level, the first word here is reduce, right? And so it's really thinking about, are there products you just don't need to buy? If they are something you need to buy, are they reusable? Can you get, a nice sturdy stainless steel water bottle? Soon we're all going to be using reusable bags, right, for the grocery store. There are other simple ways. My wife and I will take Pyrex to a restaurant when we want to do takeout and just ask them to put it in that instead of a disposable styrofoam thing. So it's just little stuff that we can do. And then, recycling when we can. And you might be asking, okay, why are you putting up a nice picture of Maldives? It'd be nice to be there right now. I'm sure this water's like probably 80 degrees. Probably really nice. But right, this is what you think of, the Maldives, right? Beautiful. But what they don't show you is this. So they literally built an island to deal with all their trash. Right? They got to put it somewhere. So this woman's name is Alison Teal. She's an environmentalist, YouTuber, and wanted to highlight, what our impact is. And, I'm sure when you're on vacation, that's the last thing you really want to be thinking about. But that stuff doesn't leave when you do. It's got to go somewhere, and it stays there for a really long time. We have a plastic problem on this planet. So this is an image from the National Geographic. This isn't one big blob of color. These are actually 48,000 individual dots. Because they did a study. They went to an island in the South Pacific called Henderson Island. It's uninhabited. Nobody lives there. But they found 48,000 fragments of plastic on that island. They found straws, light bulbs, bottle caps, full bottles that hadn't been broken up yet, fishing line, fishing nets, all sorts of stuff on this completely uninhabited island. So our reach is everywhere. And we really need to figure out what to do about all this plastic. And then I really like this graphic. It's showing how big your individual impact could be. So there's low impact stuff like upgrading your light bulbs to LED, hang dry your clothes instead of putting them in the dryer, recycling, washing clothes in cold water saves a little bit, replacing your car with a hybrid. This next one, which is a high impact one, is eat a plant-based diet. Now, I'm not a vegetarian. I would never urge somebody to become one if it wasn't the right choice for you. I would change this to say, eat more of a plant-based diet. And if your concern is the environment, here are the numbers to help you with that. So, for 1 kilogram of consumption of beef, it takes 27 kilograms of carbon dioxide to produce that. Compare that to chicken, only 6.9 kilograms of carbon dioxide for 1 kilogram of consumption. So reducing red meat consumption in particular is a really good way to have a high impact on reducing your personal emissions. Like I said, I'm not a vegetarian. I definitely try to limit how much red meat I eat. I do occasionally though, but I really do try to stick to chicken and turkey, and it really has a good impact. But if your concern is you personally and your health, the Journal of the American Medical Association recently put out a study based on people who eat red meat and who don't, and they found that eating both processed and unprocessed red meat is associated with increased risk of premature mortality from all causes, as well as cardiovascular disease and cancer. increased risk of type 2 diabetes, and a diet based on fish, poultry, nuts, all this stuff significantly lowers your risk of mortality. So, if you don't care about the environment, you probably care about your own personal health. So, less red meat in your diet is probably a good thing. Buying green energy, like the village just did, is a really great way. A big one is avoiding transatlantic flights when you can. This one is controversial among climate scientists because a lot of them travel a lot to different conferences, to universities to give guest lectures, and there's a growing movement within them to actually take trains instead of flying. Live car free if you're able to. I understand that for most of us this is impossible. We just did not develop the infrastructure to do this kind of thing, especially in more rural areas. You know, if you live in the city, okay, maybe. But again, that's not the right choice for everybody. But the biggest impact, and as hard of a topic as it is, it's actually to have fewer children. When you average over the lifetime of an individual and how much carbon they emit, it's a lot. And so, for my generation in particular, to have fewer children, which we are, the numbers show, will have a big impact on lifetime carbon dioxide emissions. So I'm just about 45 minutes. That's all I've got. If you've got questions, then I'll stick around till as long as you have them.
Okay, so I have like 10 things I can bring up. I've been looking into this for 14 years, so I knew a lot of what you said. There was some things I don't know. But for instance, okay, if we're going to go renewables, which at this point we don't know what we're going to do it. But if we're going to do that, why are we going to switch up our whole grid system, but yeah, allow 1,500 private jets to go to a Super Bowl? Yes, see what I'm talking about? Why are we still going to make lawn ornaments? Why are we? It doesn't make sense. Because all we're really doing, because when I first started looking at the peak oil in 2008, we were at 93 million barrels a day of oil production. Now we're at 100. Emissions have never gone down. They've always continued to go up, and they're going up exponentially. So if anybody was truly serious about doing anything, we would cut out almost everything that's non-essential for life and go to living a life without professional sports, without making trips on airplanes at all. We would go bulk food in a grocery store. Every grocery store should be a law, should be bulk food. No plastic containers, or very few plastic containers, because you're using oil to make the plastic containers for yogurt, for ketchup, for anything. Mm-hmm. We could do green star bubbles for most things, from detergent to shampoo to anything. You bring your own container. A Tide container could last 10 years. So to me, if anybody's going to be serious, it's not just switching out your source of energy. It's our expectations for our lifestyle. And I know that is a mountain as high as the Himalayas to get across. But electricity production is, for homes, etc., businesses, is only 18% of our emissions. Mm-hmm. So if we're going to do renewables, you're only reducing our CO2 18%, basically. And then if you're doing electric cars, etc., you still have to consider the CO2 that's produced in the mining of the iron ore to make the steel and shipping all that to make the steel and then to make the parts, and all the parts are made in different parts of the world that have to be shipped to that one factory that makes the car. So you got to consider all the CO2 that was put into the beginnings of that car from scratch. And mining is 50% of all of our emissions.
So you bring up a lot of stuff that's obviously outside my purview, and put a lot of good points. But what I'll address is that I think any reasonable climate scientist understands that we'll never be carbon dioxide emission free. It just won't happen. We'll never give up flights, all that stuff. But it's about becoming carbon neutral. How can we offset what we're doing to bring us back to a more reasonable level?
One more thing. Emissions are a separate thing from concentration of CO2.
Yeah.
Concentration is never going to go down. It's always going to go up.
That's not, no, I disagree with you on that. We could do reforestation to bring back carbon dioxide
You
levels
have
down.
to do carbon sequestration, you have to suck the carbon out of the air.
That's what plants do though.
I'm sorry?
That's what plants do for us naturally.
Yeah, but we're running out of plants.
Right, so if we replanted them, so they would,
Well, I'm reading that we need to plant, if you were gonna do enough trees to do that, you need enough trees to cover almost the whole United States.
sounds nice.
Regenerative agriculture is something that has huge potential, and I don't know if this is the appropriate venue to mention the company name, but this was a news item just within the last few days that there's a startup venture based in the Boston area that is covered by CNBC, and they are going to offer tracking of farmers' products so that you know in the grocery store that this farm produced in a sustainable way with techniques that include using cover crops in fall and winter so that it reduces soil erosion and so that it helps improve the health of the soil, captures carbon from the air, and stores it in the soil, makes it more resistant to droughts because it holds more moisture as well. It's more healthy soil. The plants grow better, the plants are healthier, so tracking it from this farm to the grocery store where you buy it, you can choose that, and you'll be happier eating that because it's better for you as well. And this has the capability to store, their goal is a trillion tons of CO2 equivalent in, I forgot how many acres across the planet, but it's already international. So this is a huge opportunity, and it is a massive thing that needs to be really encouraged, both locally, state level, and nationally. So I hope it gets picked up, and one of the scientists that is at Cornell, David Wolf, you probably know who I'm talking about.
I referenced a bunch of his work.
Good. He's working. He just testified at the House Agriculture Committee that Representative Anthony Brindisi is working with, and he talked about this. So he's got Representative Brindisi's ear, and I hope that Representative Brindisi is going to follow through on some of these things and try to convince some of his colleagues and turn around and educate people in his district, because we do have a lot of farmers, and they're suffering. So he can use this to his advantage, because there are many communities where people are watching Fox News at home at night, but the farmer next door, they don't understand their struggles, because the person that's watching Fox News, that they may have some other job that's totally unrelated to farming, so they don't have a clue of what's going on. They might have totally missed this drought, other than maybe they saw their lawn drying up in 2016, but my wife and I noticed this drought. We saw green trees dropping their leaves were dried to a crisp, and they were green on the ground in Ithaca when we went for a walk over there in 2016, and it was just heartbreaking. It was so bad that weeds were drying up. I mean, you know that's awful when weeds are drying up. So, anyway, I'll stop.
Hi, I passed around a board that asks if you're interested in clean energy communities. And Village of Owego, I don't know how many of you were from Village of Owego, but it doesn't matter because this is applicable to all our communities. There's hundreds of clean energy communities right now in New York, and what they do to become that is they do 4 of 10 high impact actions, and the Village of Owego has already completed 2 by making 100% renewable energy their default plan, and number 2 by their LED lighting. So we only have 2 more to go to be designated as a clean energy community, which not only gives us funding for different projects that we can work on to greatly increase our chances of a longer lifespan for our future children, but also I lost track of where I was going with that. We also that gives us a foot in the door for becoming a climate smart community, which involves more steps. So I hope you will come to that. It would be Thursday morning or Friday afternoon in this building, gonna be able to ask if there's a hand showing for who prefers Thursday? And who prefers Friday? Uh-oh. I'll send an email or call you to, with the doodle to find out. Thank you.
Right now, at the state level, the legislature is coming to the close of this session. In the next few days, they can either act or not act, based on what the people in this room do in the next day or two. And that is hopefully to call to support what's called the Climate and Community Protection Act. The majority of the Assembly's got it, the Senate needs to vote on it. We are very close. CCPA, you can do it, the Climate and Community Protection Act. And the goal is 50% reduction in greenhouse gas by 2030 and 100% renewables by 2050. New York, which has been slower than some states, could take a step and be a leader again. But what we need to do is not just call our senators and maybe see somebody at the Strawberry Festival, but talk to friends around the state. Call some other people and ask them to call so it can be statewide supporting the Climate and Community Protection Act. Because if we can pass it on the state level, that is a huge ramification not only for our state, but for the country and indirectly for the world. So would you support that idea?
Absolutely.
This may not be your expertise, but you know, when you showed that island, the lemon lives, actually, then it showed that awful collection. I mean, what needs to happen to that kind of stuff in order for it not to just be burned someplace and exude a whole flock of not only carbon dioxide but other foul fumes?
You're right. So that's I'm not speaking as a climate scientist. I'm speaking just as a person who has studied this. We need to think about how we consume stuff, right? When you think about who's going to the mall, it's people who can afford it, who don't care about, buying a bunch of water bottles and leaving them behind for somebody else to deal with. It's really a systematic change in how we consume. That's
what statement you made puzzled me. You said that high humidity is harmful to humans and agriculture. I can see humans, I guess I don't understand how it's harmful to agriculture. With high humidity, you have less evaporation. So I guess I didn't understand.
Sorry, I was more focused on like dairy cows. It gets too hot and dairy cows don't do well.
Okay, not agriculture, the cows themselves.
Yeah.
Okay.
Yeah.
I have one thought though about the high humidity. With high humidity in the air all the time, even if you're not getting a lot of rain, you can get funguses on plants that can kill the plants.
Yeah, that's true.
Because we see that here in the summer where you start getting spots on the cucumbers and things like that. So you could still be sort of in a drought period, but killing your plants that way.
Yeah.
Every week, we get ads showing all kinds of things that we really shouldn't be buying, shouldn't be manufacturing. And there's so many alternatives to that, but I don't see that.
This is another source of pollution of all kinds is the military, frankly. I think something like half of all the pollution that we do is done by the military. I was reading a paper that talked about when the chunks of the army were leaving Iraq, and they had these dumps, where they had all the stuff that they can, the paper, I don't know, maybe little weapons or who knows what. But they proceeded then to get rid of this by burning it, and it was terrible. It was creating a terrible stuff in the air and that kind of thing. Pardon me?
Depleted uranium.
That's one other.
Oh yeah. Oh, then there's depleted uranium. That's another thing. That is something we don't see except in the births of people who have little children who have deformities, especially how they interact where the U.S. Army was using depleted uranium because it's such a wonderfully hard metal, and so on and so forth. But it's nasty.
I mean, it's every industry. It's everywhere.
I don't want to make this more depressing, but it's
It's
basically,
depressing situation.
yeah, earlier you mentioned that you might entertain the idea of talking about methane emissions.
Sure.
And that scares me to death, because there are positive feedback loops, which if, for the audience members that don't know what that means, it's self-reinforcing cycle.
Yeah.
So there are places that are now releasing methane into the atmosphere that have nothing to do with humans, except that humans are causing the climate change that triggers those things
Right.
to start happening. The melting of the tundra, permafrost,
Yeah.
ocean depths that have stuff that has settled a long time ago and it's under deep, very deep in the ocean, under high pressure, and it's cold, but because things are warming up, that's starting to bubble up, and that is a nightmare to me, and of course climate scientists too, and I'm just wondering if you can comment on that, as well as the methane leakage rate from your colleague Bob Howarth, who has been studying that for years. That's another scary topic. Another recent one that was reported was that fertilizer production is much higher in terms of releasing methane than previously realized. So I'm sure there's more surprises on that too, but what do you think?
Yeah, sure. So methane is about 100 times more potent of a greenhouse gas than carbon dioxide. So it absorbs a lot more radiation, can re-emit it, and warm things faster. Yes, I'm concerned about the positive feedback, especially if the permafrost melts. There's methane trapped in there that could get released, warm up more permafrost would melt, more methane gets released, positive vicious cycle, positive feedback. But methane doesn't last in the atmosphere very long, 2 years, about its life cycle in the atmosphere, whereas carbon dioxide is like 10,000 years.
But methane's potency is greater,
Yeah,
and therefore the forcing is greater.
yeah, but it's currently not anywhere near the levels of carbon dioxide.
But it's coming out. And
Yeah.
they're really worried about the East Siberian sea shelf also. It's only a 50-meter deep lake sea off the East Siberian Sea. Have you heard that one? And it used to have meters of ice covering. And now Natalia Shkova and Igor Slutov, glaciologist, in 2010 she did a video, and she was saying that there was parts now that they're worried about because it's like 40 meters, it's like 40 centimeters of ice in some places. It was not, that was 2010. And now with the warming of the Arctic, it's been happening, who knows what's up. And once that ice cover is gone off that lake or sea, it's only a 50-meter deep sea, and there's trillions of tons of methane under there, and they said you only have 1% of that released, and we're dead in months. What you laughing about?
No, it's an extremist view. I
It's not.
understand the
It's
science
not
behind
just
it,
they've
but
been going there for 30 years.
no, I understand that, but we're warming, so it could get released.
Yes, there you go. So timing is really time is our biggest factor. If we're going to be doing things, it has to be things that are drastically fast.
We should have been doing things 6 years ago. Yeah.
60 years. Right.
We've talked about needing to make some individual choices and actions that need to change. And it's so easy for us to think, I'm just one person, I'm just a small person, I can't, and anything I can do won't make any difference. But I would like to quote one of the things that comes on my email that says, if you think being small means you can't make a difference, you've never been in bed with a mosquito.
Mosquitoes get crushed.
Kevin?
I wonder if you could say a few words about the disinformation campaign by basically fossil fuel industry and its impact on public perception over the last 30 to 50 years.
Yeah, actually. So I recently just recorded a podcast with some colleagues at Cornell. We read the Heartland Institute. Anybody familiar with that? They're privately funded mostly by the Koch brothers, who have a lot of money in fossil fuels. So naturally, the reports they are coming out with are anti-climate science. And I read through it, and like I mentioned, they don't at all address the physics behind what's going on with carbon dioxide. It was written by economists, so where economists get off discussing in-depth climate science, I don't quite understand. But yeah, I mean, it's money, right? Like, where's the money coming from? Who's funding it? What are their interests? If going to renewables is going to cost somebody some money, which obviously it is, right? But they're going to fight to make sure that doesn't happen. So you just got to check your sources. That's what I tell people. Where is it coming from? Who's funding it? All those folks that wrote that report for the Heartland Institute are paid by fossil fuel industry. Compare that to the IPCC's report. All of those scientists from across the globe do it voluntarily. They all have other jobs that they have to rely on for their income, but they give their time because they know that the science is right, and they're not paid for that.
One thing to mention for people, for an opportunity, anybody that lives in New York State, at least most of New York State, has the opportunity to sign up for 10% savings from community shared solar from various different companies. And it's off of your supply charge. But that is something that requires no upfront money. You don't invest in anything, you don't buy anything, you just make maybe a phone call or two, and you change the supply source to solar energy, and you save 10% off your electric rate on your supply charge. It's pretty simple, but it's very difficult to even convince people to do that. And I don't know why people are so reluctant. They're afraid because of something that happened in the past with energy supply companies. That's one thing people bring up, is they don't trust things, but it's still worth doing, and there's no long-term contract either, so if you don't like it, you can always switch to something else. And the other thing I want to bring up, just while I'm talking, is the communication problem. How do we get the press to cover this topic with the scale and urgency and sustained coverage? I know this is something that breaks your heart, but I've been puzzling with this for years now, and I don't understand it. CNN supposedly was supposed to be cable network news, and if you look at their website on a day-to-day basis, they don't have very much in the way of anything related to climate. Once in a while, you'll read a smattering of a flood report or some other, heavy storm event or something like that. Very rarely does it even tie it to climate change, and they're really doing a disservice to the public by ignoring it. So I don't know how we change that. But
You have a thought on that?
Well, just one way to respond to that is, just an example of a book, Climate Justice by Mary Robinson. I don't know if you're, but it tells stories of people who are responding and adapting to climate change. I just returned from a couple weeks in Kenya and Uganda, observing farmers, how they're doing conservation agriculture and responding to, adapting to that. So I think telling stories, not to critique your presentation, it was very good, but we have to balance our scientific presentations with the stories of impact, not only in the United States, but in Africa and other parts of the world. And hearing people's stories and how they're being impacted, that's where you start turning, hearts and minds, changing them that way.
I totally agree. I also think it's a problem with climate scientists. There are lots out there who wouldn't want me to be here right now, that don't think public engagement like this is honestly worthwhile.
why?
Because I'm going outside my lane a little bit and talking to the public and trying to educate people on climate change. There is an old mentality among many senior climate scientists to just let your science speak for itself. Personally, I don't believe that. I think we need to be out there talking to folks. But that mentality exists.
If it's not climate scientists, who's going to do it with authority? I'm floored by that mentality.
There was that situation with the letters that the climate scientists put out. What was it, 2014 or 2016? Do you remember what I'm talking about?
Yeah, with Michael Mann.
well, there's a lot of them that wrote letters about their worries of climate change.
Mhm.
So they were trying to calculate. I think it's somewhat different with some of them now over the past, like, I saw a shift around 2012-ish, maybe a little before that, where a lot more of them are putting, like Jason Box, glaciologist, he had a live interview in 2015, I think it was, and they asked him a question, I don't know what it was, I forget, but he goes, where, live, and he got in trouble. He doesn't live here anymore, he moved to New Zealand.
It's politically doomed.
Us, it is.
Forget the people who have their head in the sand, even if they're climate scientists and don't want to talk to other people about it. Sources of information for the non-academic. I agree with you. CNN is disappointing to the max. New York Times, Washington Post consistently has now a lot of reporting, has whole sections on climate and environment. I don't know other sources. What organizations, that are not only educating but advocating, do you think people should be connecting to? Sierra Club, Natural Resource Council, which?
Oh yeah. National Geographic is great. GRIST, G-R-I-S-T, is an online magazine. They do a lot of great environmental pieces. And Inside Climate News is also really good. For the other problem with academic journals is you have to pay for them. I don't know who that money's going to. It's not going to me. But if you're not a big institution that pays for those subscriptions, it's very good.
What was the second one you said,
Inside Climate News. Yep, and GRIST.
The other thing is short articles on local papers. I mean, Jerry Wiley's had a lot of articles in, and a lot of these local papers, like the Penny Saver and the Courier, and maybe even the Morning Times, it's free work for them if you write an article. So they're happy to print it.
Yeah.
I mean, it's got to be informative and reasonably well written, but they're happy to print it.
I'm collecting a series of. Anybody enjoy reading the readers' columns as much as I do? Occasionally, there's a weather climate science related one. I've got a bunch of pictures of them, and I'd like to write a letter addressing them.
So, well, I know we were talking about a lot of more or less different practices like with farming and things like that, and individual action. But truly, what really needs to change is the system with which we function. Capitalism. You cannot have continuous growth on a finite, infinite growth, on a finite planet, and that's what capitalism requires. You're always going to have new businesses, new products, new this, new that for people to have jobs. You cannot have infinite growth on a finite planet. They already have that one marker where by July now we've used all the resources that we should be using that year, and then we're borrowing resources on the rest of the year. So I just hope, and the other part of this is not just climate change, but the sixth mass extinction, which we're already in. Everybody heard about that. So with my bigger question too, and like I mentioned, if we're continuing to produce things, even equipment for renewables, we're ripping up habitat more and more and more to redo the whole grid, and yet we're worried about the sixth mass extinction because the biggest cause of any species going extinct is not hunting, it's loss of habitat. So I'm really wondering about a worldwide push on mining for all the raw materials for a whole rebuild of our grids.
So you're obviously getting into a lot of social science and stuff, but
Social science.
yeah, how we interact with the world.
Well, mining is science, not social science.
Right, but where we invest that money
Politics.
in politics. But we also have to consider, India's putting a big push right now to build coal power plants
I know.
because they want to give their citizens a better way of life, just like we did during the Industrial Revolution. Yet we have folks who are saying, oh, no, you can't do that. You got to invest in renewables. But that's not what we're doing. So it's hard to convince a country who just wants to give their folks electricity and running water to do it the more expensive way when the United States, the richest country in the world, not doing it.
The Australian government just put a big push behind mining coal. And
Yeah.
I thought,
It's cheap. Yeah.
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 I think one other thing people have to be very aware of and careful about is not just vote for somebody who says, I'm going to fight climate change. Look at what their plan is. Look at what their specifics are. Make sure they really know what they're talking about. It's easy to say, I'll fight climate change. They might mean, I'm gonna go with a lot of clean natural gas and build
Yeah,
more of
right,
these
exactly.
Nuclear.
plants.
I know.
Or whatever. So you have to really be choosable.
Really, exactly.
And just, you know, Kevin brought up, you know, the disinformation campaign. When somebody talks about something, try to read it for yourself. The Green New Deal has gotten a lot of negative press, right? It's not very long. It's like 14 pages. It's not even a bill. It's a resolution. Just try to commit to certain things. You know, there were a lot of talking points of like, oh, it's going to eliminate all cows. It's going to eliminate all air traffic. That's not what it is. So it's, you know,
It's true.
and that we're fighting an uphill battle on that.
Just want to thank you for, you know, focusing on Owego in all of your slides and all of your research, and that's not an easy thing to narrow down. So, but it makes it so, the information so much more relatable, and I really appreciate that.
If anybody has any other questions, my email's up there, as well as my lab's Twitter and Instagram, where we post updates on our research and stuff, but feel free to take my email down, shoot me questions anytime. Thank you for coming out, really appreciate it.